So thank you everyone for coming to our talk, and let's get started. So as we're just coming back from lunch, we could use some exercise. So how many of us have we're in the middle of an incident or just debugging, thrown some logs, metrics, or code at an LLM? Most of the room? All right, let's go next. Oops. How many of you have tried building an AI agent or an assistant? You found yourselves asking the LLM the same question and you're like, okay, I can build something. Okay, so glad to see that there's some people in the room. And then some of us who have been on the other side where someone in the leadership comes up and asks us, hey, this AI tool is out here, or we have many vendors, including ourselves out there as well, saying that, hey, this is all we can promise. Do you want to try it, right? So again, a few people in the room there, and then now you have built these tools. You have been either asked to use them. Have you had a reproducible way to test any of this? Anyone? Maybe? No? No? Oh, one person in the room there. So, all right. So when we started on our journey last year with all the LLMs, right? So IBM, with IBM Research, were already doing a lot of work in incident analysis and whatever have you, and then LLMs came along, right? So we folks in the team were like, okay, so what does it mean to start using LLMs for this? And then over a period of time, you'll see that, whether it be IBM or some of our competitors, these are all like public articles which someone can go and read, and they have all the claims, right? That, hey, we are doing this, we are doing 90% faster root cause analysis and whatever have you, right? So Bhavya, would you like to comment someone?
Yeah. So, okay, we've seen all the promises, but what about the reality of it? So again, you'll see a lot of articles out there talking about, first of all, whether AI is really needed. So if you look at some of the incidents, and it would show that, just 1 minute of testing would have discovered the issue rather than throwing so much investment into AI. Then even if you use AI, right, for example, Meta's AI only has 42% success rate in finding the root cause for these incidents. And not just that, there's people who are, the SREs who are using AI, some of them, show increased productivity, but there's also a lot of increased toil due to these additional AI tools. So we see a big gap. There's so much being promised, but the reality is the accuracy isn't that great, and the usefulness of these tools is still questionable. So same thing we've seen in our experimentation, testing with these AI tools, that just throwing a lot of data on LLMs is not going to get you anywhere. So we tried this. We came up with this simulated kind of incident where we had like alerts and some data like events, etc. And we gave this context to LLMs. Full disclosure, we came up with this test about a year ago, and then yesterday when I was playing with the same incident, I thought, will this incident still be tough for the latest models? And lo and behold, even the latest models like Gemini 3 Pro, Claude Sonnet 4.6, all of them struggled. So what was the issue? The issue is that the context is not clean. You'll see a lot of events, and it's like a needle in a haystack problem. The correct root cause in this case was a config issue, whereas all the LLMs got confused by a network policy which was applied but then quickly reverted. So that signal was missed by the LLMs, and it just latched onto something which seemed like the right answer, but it wasn't. And feel free to try, you have the QR codes here, so you can try your favorite LLM, do some prompt engineering, and see if you can get the LLM to give the right answer. So along this journey, we, sorry.
The other direction.
Oh, you're going the other way. So along this journey, we learned a lot of lessons. So one we talked about where context quality is way more important than using the best model out there. Garbage in, garbage out. You've heard that a lot of times. If you're not giving it the right data, no model can get you the right answer. The other thing is we want to take a more of a scientific approach to this, as we are building agents for our use case. So when we are doing this, reproducibility is key. how do we measure progress unless we can replay the same scenarios, the same fault, give it the same exact context and ask it to solve it? And then maybe Rohan can talk about the other lessons.
Yep. So question was, can we build such an evaluation framework, right? Was there something existing out there which we could build and which we could build on? But when we were out there looking for something like this about an year back, what we found was, oh, you had these environments which were like completely like offline, just like an AI researcher would come in, use an offline data set to do any of the visual analysis or whatever have you. But we know from our experience of building cloud native applications that this domain is different, right? So what started was what we now call as the IT bench effort. So again, it's Apache 2.0, it's on GitHub. Folks can go in, it's completely Kubernetes based. So the layer is where you could come in, you have a Kubernetes cluster, you deploy certain applications on the top of it, you deploy a bunch of observability tools which are open sourced and ready to use. And as a part of that, what we started to do was we started looking at some of the incidents which we were seeing from our own internal systems, whether it be the likes of the IBM software products, and then extending to what incidents we were seeing from AWS and Azure and whatever have you, and started to build this notion of what does it mean to bring those incidents into such a sandboxed environment. And then the whole idea was, could we build something which was vendor neutral, right? So whether it be our own IBM products or be any vendor out there, this was more of a mission for us, both from to prove that our agents are doing better, but also from a research perspective, we wanted the academic community to have such an environment where as they adopt AI and build certain toolings, they can come and build with us. So as you can see here, right, so we refer to an IT bench scenario. So what does a scenario entail? A scenario entails basically you go ahead and you deploy the environment. So a lot of the execution is completely Ansible based. Again, we were trying to wear the lens of what people like SREs themselves would be using, as opposed to like, we got kind of a pushback from our AI researchers, hey, this is not our preferred mode, we have a learning curve, etc. But we stuck to that one. So again, as you can see, a lot of the open source tools out there. When we started out there, our hat which we were wearing was primarily an SRE lens. And then what we started to observe was, yes, there are certain decisions an SRE can take by themselves, but it could be that they are put in certain situations which are also drawn from other domains like FinOps. A popular, popular is probably the wrong word, but an infamous incident which we were brought to was where there was a exponential cost because some malicious actor had entered into the environment of one of the large corporations. They were managing to spin up VMs with GPUs on them and then using it for mining. And the only reason that got noticed was because some FinOps professional noticed that, hey, there's this unexpected surge in some cost, and then they went to the SRE teams and be like, hey, what's this happening? And then that in turn led to them reaching out to the folks in compliance and security being like, and that's what made us think that, if we build something like this, it need not just be limited to site reliability engineering, it could extend to other domains as well. And then the next step was, okay, so you have some sample applications. So I'm hoping most of us have heard of Astronomy Shop while working with hotel telemetry and whatever have you. So that's the first application which we adopted. Now we also have Istio's book info, if folks are familiar with it, onboarded as well. And then the third step is where, we have made some initial dents, and we would expect as we go through this journey that folks in the room would join us on, right? So think about fault mechanisms as failures, which you could introduce in this sandboxed environment, again, through code changes or firing up certain load generators and whatever have you, right? So that's what is evolved. So going back to when we started, right? So a leadership, someone comes in and says, hey, can you please evaluate AI capabilities of X? You could be like, hey, I don't need any external tooling. I could build something over lunch, just fire up Claude Code, build something which you use daily. But the eventual question is, how do you evaluate? How do you go about saying what I have built is better or what someone else is offering to me is better, right? So from an IT bench perspective, this is what we came up with. It was a checklist, right? So, okay, is there hotel support already present for your application? Can your application be deployed on Kubernetes? And then, you can set up whatever data exporter you want. And then with the intention that whatever scenarios which we have been building as a part of this IT bench open source framework, could you take it and replay these scenarios in your environment for your application, right? And then eventually what you'll end up with, you have a set of fault mechanisms, you have the same set of evaluation metrics, which Bhavya will talk about later, and then you have the capability to use these different toolings, whether it be your in-house tooling or whatever vendor you may go to, right? So leading to more like an apples to apples comparison overall. So just for people to start getting some familiarity, right? So you can see that within this small YAML snippet, if you will, this is all. If you have a Helm chart, this is what you basically need to bring in your application, right? So you would just go, plug in the corresponding Helm chart values. There might be some template configurations that you need for your application, and that's it, right? Now you just go ahead, run a bunch of Ansible playbooks, and you will have the application deployed into this IT bench environment, which you could have on your own internal clusters or whatever have you. Similarly for scenarios. So what is a scenario, right? Going back, rehashing, it's a combination of the observability stack, the application, and the fault mechanism. So here you can see that we have created a fault mechanism where due to some deployment changes, you now have an unsupported architecture image which is getting deployed into your environment, right? Or maybe someone made a change to their build scripts and now they had it going around building for an incorrect architecture as an example. And here you can see that the name checkout of the targeted workload, so checkout is one of the components in Astronomy Shop, but here again you could see if you had your own application, you could basically change it to that, right? So basically reusing these fault mechanisms for your own environment. And so then, so where do we go from here, right? So we've been thinking about, for let's say a community at large, if we go back and we start looking at some of our own internal incident reports, is there some summary or some sort of a postmortem I can get from those reports? And then, and try and see, okay, the failure happened, right? As a part of all our investigations, we go ahead figuring out, okay, this is why it happened and whatever have you. What would be a representation of that? And then what we have landed up creating are like two experiences as a part of it. So one experience is where, let's say you want to be where, hey, I don't want to use an LLM. I just want it to be completely like, script driven. I want to contribute the code, whatever have you. You basically go in, run, make scaffold fault. It will go ahead, run through the execution, prompting you, hey, what fault mechanism you want to create, etc. It will create the relevant placeholders for you into the IT bench environment. And then you can go ahead and deploy that, right? So that's this one experience which one can go for. In the case of an LLM-assisted experience, it's more like we have developed like a Claude Skills. Folks in the room familiar with Claude Skills? Some? No? Some? Yeah. So what we were able to do is we have tried to leverage that, ground it into this Astronomy Shop demo application. So all what you need to do is just bring in an incident report, right? So, and let's see if the tech permits us here. So right before our discussion here, I basically went online looking for, hey, are there some incidents which we could look at? And then I was like, okay, so there was this incident report which showed up. This is from an AI startup, again, promising things to do in the landscape. And then this entire experience from there, right, backed by Claude Skills, not taking any credit there away from our folks at Anthropic, is able to drive in through this step by step. So it goes in, okay, it goes, fetches, no, okay. It goes ahead, it goes fetches. Once it goes ahead and fetches the scenario, it tries to come up with some summary of the incident, right? Once it draws some summary, okay, I'll have to probably hit no here so that it doesn't keep scrolling. And then it goes, it creates, some summary of the incident, and then it starts to ground it into the IT bench framework, right? So, which means what does it mean in the context of hotel demo? And are there services inside hotel demo which it can leverage? So in the first execution, right now, if it was a human was not intervening this interaction, you will soon see that what it tried to do a few minutes ago was just introduce the corrupted image for the hotel collector itself. And we as practitioners know that if you basically botch the hotel collector itself, you will have no observability data coming in, and hence, the scenario is null and void. So you as a human can go in and then provide some input saying, hey, that may not be the right, let's see, I'm just trying to scroll through here till I get to the point. Yeah, where I basically go ahead and tell it, hey, this is not the right thing to put it on. You go and you go to the checkout service, and then it starts looking into the checkout service, and it goes and does the same thing for the checkout service, right? Instead of trying to do it for, and then as a part of the execution, as you can see, I can guide it through steps where it's basically now going ahead and trying to run the scenario here. So it's basically showing that, okay, it's gone ahead and verified that now it has, an invalid image pushed and updated to the checkout service and so on, right? So the idea here is basically to make the experience as seamless as possible for any practitioner to come in and contribute, whether it be the fault mechanisms or the scenarios, or basically take this environment back to your estate and see, how do you go about evaluating any of the AI toolings out there. So going back to our charts. Yep, so that's where we went from, going from incident scenarios, and then, folks who are interested can also contribute PRs on that. So now that we have run a scenario, the question becomes, what does it mean to go ahead and start evaluating how the performance of the AI agent was? So again, when we first started off, we had our evaluation was kind of secret, but off late in the last couple of months, the team has worked to go ahead and make it open sourced as well. So again, if you go to the main IT Bench Hub organization, you will see that even the evaluations is open sourced for you to bring in and start evaluating. So Bhavya, would you like to cover some of the metrics?
Okay, so again, when we are building a benchmark, so the obvious question is, how do you measure whether your agent is successful or not, right? So in this task, we have kind of two subtasks. One is diagnosis, which is whether the agent get the correct root cause or not. So again, if you think about the example slide I showed in the beginning, in that case, the agent did not get the root cause right? So that is the diagnosis part, and then you have mitigation, which is the final goal in some sense, which is whether the agent cleared the alerts or not, so it fixed the issue or not. And then, of course, you would like to measure how fast or slow was it at correcting the issue. So to dig a little bit into the actual metrics, so for diagnosis, we use something called pass@k, which is used quite often in the AI literature. So it basically measures whether the agent got the root cause entity right or not within the first k attempts. So in some sense, it is also an attempt to measure the robustness of the agent, right? So let's say we run the agent 10 times, but it only got the correct root cause 1 in 10 times, right? So that's not really useful, versus the agent getting it right every time. Beyond just getting the root cause entity right, we also want to measure whether the reasoning is right or not, right? So what is the exact reasoning, so the why behind the incident. And this one is a little bit harder to measure because it's all natural language, right? So it's not like one entity, so one service, but it's like you can express the same reasoning in multiple ways. So it's a little bit harder to measure that. Then in terms of mitigation, you again have pass@k, and I'm sure you're all familiar with mean time to resolution, which is the end-to-end clock time the agent took. And I would just like to give a quick shout out to Nicole, who introduced this mean time to W2F in this conference. So when you're building agents, you should always think about the usefulness. Ultimately, humans, your SREs would be using it. So we don't want the agent to do something that confuses them even more, right? So we want to reduce the burden or the friction to the SREs. So yeah, these metrics are great, but always think about the human factor. So how are our agents doing on the benchmark, right? So again, when we started this journey, it was about, I think, late 2024 is when we started. And at that time, and I think even now, React is one of the popular architectures that is used, which is basically use the LLM to do everything. Right, so the LLM does the planning, it uses tools to interact with your environment, it'll collect the data, analyze the data, and so on and so forth. So as you can see, the agent didn't do a great job. It was only getting about 14% on the diagnosis task, and mitigation was even worse, about 11% or so. So not great, right? So what did we do? We looked at what the agent was doing, tried to do some error analysis, and we found some obvious things like, okay, it hallucinates, it's not able to plan correctly, it's wandering about. So the environment, as you know, like a Kubernetes environment can be huge, right? There's so many services. So it can take a lot of detours and just get lost in the huge environment. So we took those as lessons, and one of the members of our team, who is a domain expert, thought of using the application topology. So it's a way to guide or scaffold the LLM and constrain like the search space. So so we start with the services in the alerts and search only within the neighborhood of those services. And even within that, right, we have a deterministic way of providing the context. So the LLM's job is reduced. It doesn't have to make tool calls. It doesn't have to understand the raw context. A lot of it is engineered in that way. And this agent does a lot better. As you can see, it's close to 95% pass at 3. Small caveat, this is evaluated on a snapshot of the data. We are still in the process of evaluating it on the live environment, but we expect the numbers to be around somewhere in that ballpark. So that's great, right? I think the problem is solved. What do you think? So we can, like, all SREs can stop working and let the agent do our jobs. Fortunately, that's not the news. So this is where we would like to invite the entire community and need your help to evolve the benchmark and participate in the benchmark as well. Do you want to talk about this?
Yep. So as you guys saw, right, from the more targeted exploration, which our colleague Saurabh, who's also on the talk, went ahead and explored, right? You can see the improvement which he got in terms of the benchmark. But what we have realized is that even when you look at the fault injection mechanisms which are present in the part of the benchmark, it around coverage is around 15% of all the universe of fault mechanisms which you could have, what we see in one of the large cloud providers or whatever have you, right? So that's where we are hoping that the community will come in and help with there are two intentions here. One is we help folks build better agents, which in turn become better assistants for all of us. And also to the part where we see this as knowledge sharing, right? So there are students out there in grad schools that we interact with who are interested in this domain, and they are very keen to start, tinkering with, hey, what does this IT incidents look like? What does it mean to be an SRE and things like that? So whenever we look at, and that was a realization, like both being from UIUC, that was one of the realizations we had as we went on this journey. And then also if there are any other agent developers in the room, right, we'll be more than happy to see how do your agents or methods perform on the IT bench. There's also like a leaderboard which people can come in and participate in. And then, last but not least, for us, it is more about making AI agents better, and then as in the morning talk it was stated, right, it's all about building trust. So how do we go about building trust as we go on this journey? And then, so feel free to scan this QR code. This should take you to the parent repo of IT Bench, and give it a shot. If you have any questions or any point you filed a bug, please go ahead and create an issue, and we'll be more than happy to hear any thoughts, any PRs, any contributions, or any like we were talking to our folk colleagues at Red Hat the other day, and they brought up like, hey, we have this CI/CD pipeline which we use, and we think that there are these 10 incidents which we have seen in the last 3 months, which we want to contribute to the benchmark, right? So that's how we see this continuing to evolve and stay Apache 2 licensed and whatever have you. And then, as a part of one of our collaborations, another QR code for you to scan. This is more about like a survey. This is not a survey being done by IBM. This is being a survey done by our alumni at UIUC, where they want to hear from SREs to see how they are using AI today, if they are using AI, and if it helped you in do certain things in a particular way, how did it help you, right? So the first is more like a 10 to 15 minute conversation to learn more about what you're doing, and then eventually leading to a longer interview. And again, right, this is all with the intent of they're going to go ahead and publish these findings and share with the broader community at large as to how you as a community are thinking about consuming some of these things as a part of your day-to-day work. And yeah, I think we are, this is just a bunch of fault mechanisms which we have already implemented as a part of the IT bench framework. And anything else, Bhavya, you'd like to add?
I think so.
All right, yep, that concludes our talk.